Okay, so we're back here in 2.1. We've just finished up talking about extended distributions. So we're going to continue on. And our next example is to find the class boundaries and the class midpoints for the distribution that we created. It says above, but it's on the last page, our TV distribution. So we can find the boundaries relatively easy. Remember, we look at the upper boundary or the lower boundary of one and the upper boundary of the other. And if we look at how we get from 1600 from 1599, so this is the upper boundary of our lowest class, and this is the lower boundary of the next class. What we do is we subtract. This is 1, and then you just divide it by 2 to get the midway point, and that's going to be 1/2 or 0.5. And then we take that and we add it 1599 plus 0.5. So to get the next one, this is 1599.5. As our definition said, we just add 100. Gets us 1699.5, and you continue this on until you get all the way to the top. So we're going to construct our frequency distribution, our extended frequency distribution here, with our classes, which range from 19 to 1999, 1800 to 1899, 1700 to 1799, 1600 to 1699, and 1500 to 1599. Our frequencies: 5, 4, 6, 3, and 2. And now we can add in our boundaries. They get their own column. So the boundary for this first one, the upper boundary is 1599.5. So if you go back, remember, we can add or subtract the class width. This was adding class width to get the next boundaries up. So this goes up 1699.5, 1799.5, 1899.5, and 1999.5. So now to get the lower boundary for this, we subtract 1599.5 minus 100, gives us 1499.5. And then we add 100 to that all the way up. You can see the pattern. This is 1599.5, 1699.5, 1799.5, 1899.5. Now, if you're looking at this, these are the boundaries. And you go, what happens if we get something that is 1899.5? Well, it comes down to how you are structuring your data. And some people will put that in this class because it's got an 1800. But some people will put it in this top class because it's bigger than 1899. It just comes down to how you do that, and you would give that in a key for your frequency. So you would say boundary values go to the next highest class or go to the class below, however that happens. And then it also says find the midpoints of each class. Again, we could do that with a relatively short trick. So we take our 1500 plus 1599, add that up and divide by 2. Well, this is going to be 3099 divided by 2, which is going to be 1549.5. So our bottom midpoint is 1549.5. And then again, we can just add our class width, which is 100, to get the next ones. Or if you started with the top one, you would subtract your class width to go down. But this means 1649.5, 1749.5, 1849.5, and 1949.5. So this is another reason we like easy to look at class widths, because it makes calculating the boundaries, midpoints, and stuff like that really simple and quick. So once you find one, you're just doing a simple addition or subtraction depending on where you start and what you're looking for. Okay, so that's an extended frequency distribution. We're going to be making a couple more extended frequency distributions. So first we have to talk about relative frequency. So the fraction or percentage of the data set that falls into a particular class is given by the relative frequency, which I frequently, pun intended there, simplify this just to write REL FREQ, and this is our frequency f over n, so where f is frequency and n is sample size, which can be found by adding up all of your frequencies in your distribution. So our sample size here, if you add these up, is 20. And you'll see this n equals capital sigma of f sub I. So the capital sigma just means add everything up. F sub I means all frequencies until you get to the last data point. So you can kind of translate this as add all frequencies. Okay, so in this example, we're going to find the relative frequencies for the TV distribution, and then we're going to add them to our frequency distribution. So we're going to have our class, our frequency, and our relative frequency. So 1900 to 1999, 1800 to 1899, 1700 to 1799, 1600 to 1699, 1500 to 1599. And our distribution 5, 4, 6, 3, 2. And so the relative frequency, look at our sample size, we add this up, sum of all our frequencies equals 20. 5 plus 4 plus 6 plus 3 plus 2. So relative frequencies, to figure this out, we just take 5, divide it by n. 5 over 20 is 1/4, or 25%. Now, you don't typically have this calculation, you would have this. So in the next ones down, I'm not going to do the calculations, but we would do 4 over 20, which is 1/5, or 20%. 6 over 20 is 3/10, or 30%. 3 over 20 is just 3 over 20, and that's 15%. And 2 over 20 is 1/10, or 10%. And you'll know you've done this right if you add these up. 20 plus 30 is 50, plus 10 is 60, 15 plus 25 is 40, 40 and 60 altogether make 100%. And percentages, remember, you're just taking your fraction, making a decimal, multiplying by 100. So this is a relative frequency distribution. It has frequencies and relative frequencies. All right, so next up we have cumulative frequencies. So cumulative frequency is the sum of frequencies of a given class and all previous classes. The last class's cumulative frequency is the sample size. So this is a little specific to when you need this, when you don't need this. It's not something you're going to be calculating all the time. But when you make a cumulative frequency like we're going to for the TVs, what we mean by the last class's cumulative frequency is the sample size. Whatever your bottom frequency, whatever your bottom class is in your distribution, that's always got to be the sample size. Cumulative frequency. So our classes, writing them again real quick. (1916). And our frequencies 5, 4, 6, 3, and 2. So the cumulative frequency of the top class is 5. That's all it's come. The cumulative frequency of the bottom class now is 9. The cumulative frequency of the middle class is 9 plus 6, 15. Cumulative frequency of this class is 15 plus 3 is 18. And the cumulative frequency of our bottom class here, 18 plus 2, or our sample size, 20. So you'll know you've done this right if you hit your sample size. And you can check it as you go. But it just basically, the cumulative frequency acts as a counter. It counts how many data points you have to show that all of your data points were included in your frequency. So you can oftentimes think of your cumulative frequency as kind of your checker to make sure that your classes were constructed properly and that all your data points were included. Because if you get down here and you've done your additions correct all the way down and you don't have your sample size, you have an issue. So a lot of times the cumulative frequency will be used to make sure all data points were included in the distribution. So here at the end, this is a practice problem for you to try out on your own. Create a frequency distribution that includes the class boundaries, class midpoints, relative, and cumulative frequencies, and has 8 total classes. And that's going to be a question in Canvas that you'll be able to submit for some credit. So you can start working on that now.